Tell me.
Hypothesis testing.
Okay, so what exactly you remember in the previous class? What is the use of the first of all hypothesis testing? Hmm? Okay, Sunny, did you attend yesterday class or not?
Yes, Anand.
Tell me what exactly I explained in the previous class recording about hypothesis testing.
Is used for analysis of populations parameters.
Hmm?
Analysis for population parameters.
Analysis of?
Population.
Okay. So if you are not followed yesterday class, at least you can try to be understand for this particular session. Okay.
Okay.
See, yesterday we start recording about hypothesis testing, right? Basically, this is the statistical hypothesis. What it is? It is one of the statistical hypothesis. Okay. So basically, it's a statistical hypothesis recording about some assumptions and some reality. Okay. So statistical hypothesis is an assumption about population parameters. So you have some kind of real data, okay? So and we have some kind of assumptions. Whether your assumption, which is equal to, or which is your assumption which is equal to population, which is equal to your real world or not, that we can able to do that. Exactly, we are calling it say statistical hypothesis. Okay, one more time. Statistical hypothesis is an assumption about the population parameter. Clear or not? Clear, right? So there are two type of statistical hypothesis testings are there. The first one is the null hypothesis. The first one is the null hypothesis, and second one is the alternate hypothesis, alternative hypothesis. So usually the null hypothesis we can represent it with the, okay, we can represent it with the H0, and alternate hypothesis we can represent it with the HA or H1. Okay, you can use any one of it, either HA, either H1. Is it clear? So what exactly the null hypothesis and what exactly the alternate hypothesis? Let me try to be observed now. Let me consider alternate or null hypothesis. Okay. So null hypothesis, the sample occurs purely from the choice. Because someone is joined with name of Smith. Okay. So let me consider you have some kind of sample data, right? Sample occur purely from the chance. Okay, and so alternate hypothesis in the sense it was influenced by the some random data actually. Okay, so alternate hypothesis which always be either equal to, okay, equal to, and for example, alternate hypothesis when you're comparing with the mean of two things, okay, so which is always equal to positive term only we should use it. Okay, alternate hypothesis which is the negation or it's a false of the alternate hypothesis or null hypothesis. It's both are quite opposite to each other. Okay, is it clear? This point is clear or not?
Yes, it's clear.
Okay.
Yes.
So now we can able to go for any kind of hypothesis, okay, or you can go for any kind of hypothesis testing. So when you are doing this kind of hypothesis testing, you might be getting the two kind of errors actually. One is the type 1 error. What about second one? One is the type 1 error. What about second one? Type 2 error, right? What exactly the type 1 error and what exactly the type 2 error? Okay, actually null hypothesis is true. Actually null hypothesis, actually it's a true. Actual thing it could be the true, but we found as it was false. Okay, we predicted as the null hypothesis is false, but actually it was true. Then this type of error we are calling it say type 1 error. Type 2 error in the sense you got as a true, but actually the null hypothesis is a false. Null hypothesis is a false, but you got as the true. Okay, I mean you're accepting the null hypothesis, but actually it's a false. Actually null hypothesis is a false, but while you're doing the hypothesis testing, we're accepting the null hypothesis. That kind of error we're calling it same type 2 error. Okay, so usually we are getting this kind of errors. We need to understood those particular things. But when you're doing the testings, when you're doing the hypothesis testings, okay, so there is a two things are there. One is the one tail test, okay, and second one is the two tail test. Okay, so when you're doing the hypothesis testing, it might be one tail test or it might be two tail test. What exactly the one tail test and what exactly the two tail test? Let me consider two tail test in the sense, okay, so when we have one particular data, when you're distributed, okay, it was normally distributed, right? So you are comparing the mean one side only, okay, only you're comparing less than this area, okay, you're comparing only this side, only one side. Then this type of thing we are calling it same one tail test. For example, we have a data something like this, and you're comparing the one particular value with a greater than of this one, okay, less than of one particular value, less than of one particular value, it is a one tail test. As well as you have one particular significant value, it was more than this particular significant value, right? So greater than of this particular value, that is also it's a one tail test only. Okay, this is also one tail test, and this one also it could be the one tail test. Clear? Or else two tail test in the sense we should be considered the two sides. We should be considered the two sides. Okay, the data, the value, it was in between these two things. Okay, so it was one value and this is another value. The data, it was in between this range. Okay, not less than this one or not greater than this one. Okay, maybe it was in between these things. That particular situation, we are considering the two confidence intervals. Here we are taking only one confidence intervals. Here also we are taking only one confidence interval, but we are taking the two intervals, right? When you are taking the two intervals for the hypothesis testing, that we are calling it say two tail test. Okay, the examples of the one tail test and two tails tests are when you're comparing one thing, okay, mean of one particular one which is equal to the another one. Okay, let me consider this is hypothesis, null hypothesis. I always told you null hypothesis is the equal or greater than or equal, less than or equal, those kind of things only we should use it. Okay, so it is equal. By the time the alternate hypothesis, it was not equal, right? Is it clear? So this is the equal in the sense what it was, you're considering the some two intervals. Okay, so this is the two tail test. Okay, so I hope you got it right. Equal to, for example, mean 1 is greater than mean 2. This is what is a one tail test. One tail test is what? It's a right side one tail test. Greater. Okay, greater means okay, right sided. Okay, mean 1 which is less than mean 2, then this kind of thing we are calling it same. Okay, left side or left one tail test. left one tail test. So you have to remember these things, guys. When we have some kind of means, when you want to comparing the two things, some situations we have to consider the one tail test, or sometimes we have to you have to be consider the two tail. Okay, two tail in the sense equal or not equal, and one tail in the sense less than or greater than. Those particular situations we have to be consider the those particular two one tail and left one tail and right one tail. It whatever it is, it's a one tail. Okay. Any more questions regarding about one tail and two tail? One tail hypothesis testing and two tail hypothesis testing. Two tail in the sense we need to consider the two intervals, and one tail in the sense we should be considering only either left either right. Clear?
Yes.
If you have any question, please let me know.
Anjan, you're muted.
It's my fault. Okay, statistical hypothesis, it should have some kind of steps. Okay, we have to follow those particular steps only when you're doing some kind of statistical test. Okay, the first step is we have to state the hypothesis, what could be the null hypothesis and what could be the alternate hypothesis. We need to state as the first step. After you state, then what could be the second step? What could be your second step?
Testing the hypothesis. Testing of hypothesis.
Sorry?
Testing of hypothesis.
Testing of hypothesis means what? So
Yeah.
we need to determine the significant value. Determine the significance level or value, whatever it is. Okay, so this is the significance value which is given by the domain expert. Okay, so usually the significant value people are considering the 0.01 or 0.05 or else 0.1. Okay, either this is the three values they are considering, but most of the time it was 0.05 only, but it is not constant for all scenarios. Depends upon the your problem statement, the significant value can be changed. This is not constant, it can be changed for every time. Okay, depends upon the domain, which domain we are considering. Based upon that particular domain, the significant value can be changed. Clear? Once if you have done the determining the significance value, then we have to calculate the and the p-value with help of this test statistic. Okay, test statistic. So with help of this test statistic, we have to be calculated the p-value. Calculate the p-value. Okay, so with help of this particular two values, significance value and p-value, when you're comparing this p-value and the significance values, we can able to reject, either fail to reject the null hypo or alternate hypo. Okay, so we have to take the decision whether it is the rejecting or fail to reject the null hypo. Fail to reject null hypothesis in the sense accepting the null hypo. Reject null hypothesis in the sense accepting the alternate hypo. Okay, so how we are doing? So based upon the p-value. Okay, so for example, if the p-value is which is greater than the whatever the p-value we calculated here, which is greater than the significance value, significance level, then which means that failed to failed to reject the null hypo. So simply accepting the null hypo, which means that accepting the null hypo. Okay, if the p-value is which is less than the significance value, which means that reject the null hypo. So we need to be remember this particular thing. Okay, don't confuse yourself. Your p-value and your significance value. P-value is different and significance value is different. Significance value which is given by the domain expert, or else it could be the constant, it was 0.05. If the p-value which could be calculated by the different kind of test statistic. So with the help of any one of the test statistic, we have to be calculated the p-value. If the p-value is the greater than the significance value, we should accepting the null hypo. If the p-value is the less than the significance value, then we need to be rejecting the null hypo. Clear? Rajesh?
Yes, it's clear.
Okay. Google with Rajesh. Actually, your session for Python, it was 7 o'clock, 7 a.m. as for IST. Okay, you are in statistics class.
Okay, sir.
Okay, so this is the things we need to remember, guys, when you're doing the statistical test. Okay, so here test statistic, right? How we can calculate this? So I already told you this is the significance value which is given by the domain expert, and we need to state the hypothesis based upon the problem statement. We have to state this particular hypothesis, but here we have to calculate the p-value, right? Depends upon the test statistic. So there are different kind of statistical tests are there. We have different kind of statistical tests are there. The first one is the t-test. Under the t-test, we have the multiple tests are there. One sample test and two samples test and paired sample test. Okay, or else different other t-tests we have it. And meanwhile, we would like to go for z-test actually. So when we should use the t-test and when we should use the z-test, I definitely explain you. And here z-test also, we have the one sample z-test and we have the two sample z-test and we have the paired sample z-test. Okay, different kind of statistical tests are there. We would like to go for understanding one by one. Okay, once we are understood the how the t-test is working, and once if you understood how the z-test is working, and when we can use the t-test and when we can use the z-test, definitely we'll talk about it. Okay, both are used for same purpose only. Z-test and t-test are used for same purpose, but in a two different situations, two different scenarios. I will explain you these two tests, when to use and when not to use, or when we should use the t-test and when we should use the z-test. I can explain you once I done the concepts of the t-test and z-test. But the way of approach could be the t-test and z-test is the same, and the purpose is also same. Okay, now let's side heading one sample t-test. One sample t-test. So when we are talking about one sample t-test, what exactly you are doing here with help of the one sample t-test? So here, your population mean, you're comparing the population mean, right? Okay, your population mean is same or equal. Instead of same, you can say that population mean is equal or not to any one constant value. Any one value. Okay, we have one constant. So you have one population, you have one sample. Okay, let me consider you have a population something like this. This is my population. Okay, this is my population. Okay, this is my population. So this is the population. From this particular population, you might be getting the mean, right? This is the mean which will be comparing the one constant value. So here, so this is the population. From this particular population, what we should do, we have to take some kind of sample. Okay, we are not considering the entire population because of we don't have enough data. So you have only mean value of the population. You have only mean value of the population and you have the sample data. Careful observe here. So careful observe here when one sample t-test, how the one sample t-test is working. So basically you have only population mean. We have only population mean, but you don't have any kind of population data. We have only population mean is there. We don't have any kind of population data elements. Okay, but we have sample data is there. This is my sample data. This is my sample data. Okay, so it may have some kind of elements. It may have some kind of elements, and with help of this particular sample data, this is the mean which is equal to the any one of the constant or not, one value. So which is equal to one value or not, that's my question. So from this particular thing we have to state the null hypo. Null hypo in the sense I already told you, so which is equal, right? So my population mean which is equal to some constant value. Okay, so the constant value we can consider the mean mu0. This is my constant value. Okay, so the time my alternate hypothesis, it was mu is not equal to alternate hypo. So mu is which is not equal to some constant value. This is my step number 1. Okay, so this is my population, right? When we have some population, you should have sample size, right? That's my mean. That's my n. That is my n value. Okay, and when we have sample data, you can calculate the mean, right? That's my sample mean. Okay, and when we have sample data, we can calculate the standard deviation, right? Okay, and this is my step 1. My step 2 is determining the significance value. My significance value, for example, 0.05. Okay, my significance value is 0.05. Now we have to calculate the p-value. So my p-value, if you want to calculate it, we should know the t-value. If you want to calculate the p-value, you should know the t-value and we should know the degree of freedom. Okay, so first we have to calculate the t-value. If you want to be calculated the t-value in one sample test, you should know the formula. The formula is sample mean minus population mean by standard deviation of the population sample by square root of the sample size. This is the formula for the t. And degree of freedom means total number of sample size minus 1. This is called, it's a degree of freedom. So when we know the degree of freedom, when we know the t-value, we can calculate the p-value, right? Okay, so how we can able to calculate the p-value? It was very simple. P-value calculator. So if you are using the online calculator t-test, so we can use the online calculator. Okay, so you can go for this particular statscalculator.com, p-value from the statistics. Here we have some p-value and degree of freedom. So you can have the confidence intervals, right? For example, it can be one-tailed test or two-tailed test, right? Consider it's equal, right? So that you can consider the two-tailed test, and the confidence intervals we can be considered whatever it is. Okay, then we just click on the calculate. So you will get your t-score and this is your p-value. Okay, so from online also we can able to calculate the p-value from online statscalculator.com. Okay, or else we have the t-table. T table. So when we have a T table, we just look this one. Yes, it's a two tail, right? So T value is how much? T value is how much? Some value. You might be getting some constant value, right? Okay. Let me consider this is your T value. This is your T value. Okay. And for example, the degree of freedom is 8. Oh, sorry. Your degree of freedom is 6. Okay. So whatever we have it some value, this is the your P value actually. This is your P value. So you are calculated the T value from the formula, and the degree of freedom you already know it. So with help of these two values, we can able to calculate the P value. So from the T table also we can calculate it. So this is the things we should go with manually, but we have a coding. From the coding we can do it. Don't worry about it. Okay. Is it clear? So here we should remember the some kind of assumptions. When you're talking about the statistical test, we need to remember the some kind of assumptions. The first assumption is whatever the sample data we have it, that particular variable, okay, no outliers. We should remember this kind of assumptions. Assumptions of that particular variable is that particular data, it should have no outliers. How can you say that no outliers? When we are calculated, when you are plot the box plot, and the plot it's showing you as a middle and min max, we don't have any kind of extreme values. Okay. And normality, the whatever the data sample we have it, that it could be follow the normality. Normality in the sense when you are plot the histogram, you will be getting the curve in the parabola, right? Curve, right? When you are plot the histogram, you will be getting the plot something like this. So this is the thing we are calling it's a normality. Okay, box plot will help you. Is there any kind of outliers are there or not? So these are the assumptions we need to remember actually. Okay, these are the assumptions. If and only if it is satisfied, then only we can able to do this particular things. Anyway, one more time I want to tell you guys, from the one tail test you have to be calculated the your T value, okay, and your degree of freedom. So this is my sample data. My sample data is 1, 5 and 6 and 7 and 8 and 9. Okay, and for example my population mean is let me consider it was 5.8. This is my population mean. Okay, but my question is, my population mean is equal to the 6 or not, or my population mean is 6 or not. Okay, that means this is my population mean is 5.8, right? This is the 5.8 which is equal to 6, which is equal to 6 or not, that I want to be calculated. Okay, so this is my alternate null hypothesis, and alternate hypothesis is my mean is not equal to 6. Okay, so we just substitute this all values. So if we have this one, you can able to calculate it the standard deviation. So your number of elements are n is 6, so degree of freedom is 5, and we can do it, right? The same things we will do with help of the coding. So how we will do it? We just open the Anaconda Navigator. Yes, very simple thing, guys. Don't confuse yourself. It's the code. It could be available in the internet, but just to understood in a real time, also the same scenario we should use it. The formula could be the same, but the data can be different. Okay. So let's go for your folder. So hypothesis test. So in Python programming language, we have the zypy.stats is there. Okay. So we have to import this particular stats, and this is my data. Okay. This is my sample data. Okay. So you have to be go for, we have to go for calculate, you are going to be calculated the t value. Okay. This is my p value. Okay. So this, you are just giving this entire data, you're just giving this entire data. Okay. And so now this particular t test one sample, you're providing your sample data, and your population mean also you provided. When you're providing the population sample, population mean and the sample data, which is giving the one particular value, this is the value we are calling it's a t value. Okay. But automatically the Python is providing the p value as well. So when the p value is providing, okay, this is my p value, right? What I told you, actually p value is less than the 0.05, my significance value, let me consider 0.05, then we have to be reject null hypo. When the p value is greater than the 0.05, then we should accept the null hypo, right? So here my null hypothesis is, my mu is, my population mu is, it's a 15, my population mean is 15. My alternate hypothesis is my mu is not 15. Okay. So here the population mean I'm considering as the 15, and I'm giving the sample data. Then with help of this one, we calculated the p-value. Here my p-value is, it's a greater than the 0.05, which means that we should accept the null hypothesis. When you're accepting the null hypothesis, which means that my mean is, which is equal to 15. Clear? So you have to remember this particular formula, t-test underscore lsamp. If you not remember this particular formula, whatever I explained in a theoretical part, that things we should remember it. T and degree of freedom, and with help of that one, we have to calculate the p-value. Okay. Any questions? Same thing we can try with our language. Same thing we can try with our language. So here we should remember only formula, guys. In a stats, we have the t-test underscore one sample is there. With the help of that one, we can able to calculate the p-value. Remind me later. So here, this is my data. Okay, this is my data. So this is entire data. We are assigning to some c of, so c in the sense it is some constants, right? So we are creating some kind of vector. This vector of elements we are assigning to the one particular variable. This is my sample data. Okay, this is my sample data. So let me consider, this is my sample data. So this is entire data we are giving, and as well as your population mean also you're providing to t.test. So this is the formula which is giving you one sample t-test value. Okay, this is your t value, this is your degree of freedom, and this is your p value. If the p value is, it's more than the 0.05, you should accepting the null hypothesis. That means alternate hypothesis true mean is not equal 15. Okay, 95%, this is confidence intervals. That means the mean it was in the range of 13 to 15 only. So this is the way we can use the t-test in R, and in Python we can use the, in Python we can use the, in the stats we have the t-test underscore one sample. Okay, just noted this particular formulas, guys. Just note this particular formulas. Once it is run, please let me know. Guys, RStudio is a very simple thing, same like a Python. So here we're assigning the some vector of elements or sample data to one particular variable with help of the t-test and t.test. And so we are providing two things. One is your population mean, one is your sample data. So which is giving your p-value and t-value and degree of freedom and everything, which is providing degree of freedom in the sense total number of elements minus the 1. Once it is done, please let me know, guys. Guys, we will continue the session by tomorrow. Okay, and regarding about continuation of the t-test, we have the 3 more t-tests are there. Maybe if we have the time consists, then I will finish it t-test by tomorrow session itself. Okay, and try to go for understanding different articles on the t-test. Bye guys, see you, take care.
Yeah, take care.
Thank you.
Okay.